Welcome. Let's take a look at evaluating a definite integral using the substitution technique. We have the integral here from e over 2 to 5 of 7 over x times the ln of 2x in the denominator, dx. And just as a reminder, one way of interpreting this definite integral would be the area under this curve from e over 2 to 5. So as we think about evaluating this integral using the substitution property, we start looking for places within the integrand where there's composition of functions or where there might be a case of one part of the integrand being the derivative of another part. But to help me get started, my preference is to take any constants like this 7 and move it in front of the integrand symbol. So I would have 7 times the integral from e over 2 to 5 of 1 over x times the natural log of 2x dx. And now I can focus on this function, this integrand. Now as I look at this, I see the presence of a natural log, and I know that the derivative of the natural log of x is 1 over x. So I'm kind of thinking, maybe being hopeful, that if I choose u to be this natural log of 2x, that might actually work out for me. So let's go ahead and give it a try. So we're going to let u equal the natural log of 2x. If I do that, then du will be 1 over 2x times the derivative of the argument of the natural log, that's 2, dx. Note that my 2's will divide out, and basically my du is 1 over x dx. So I'm going to rewrite this to help us see the various components. So we've got 7 times the integral from e over 2 to 5. We've got u is our natural log of x, and that's in the denominator. So we're going to think of that integrand right now as 1 over the natural log of 2x times 1 over x. Think about how we multiply fractions. 1 times 1 is 1. Natural log of 2x times x is x natural log of 2x dx. So I can see in writing it this way that I can replace natural log of 2x with u, that I can replace 1 over x dx with du, and what's left is I need to replace my limits of integration, because 5 and e over 2 correspond to values of x, and we're transforming our integral to be situated with values of u. So let's go ahead and find our new limits of integration. Our original upper limit of integration was 5. So our new upper limit of integration, a value of u, is going to be the natural log of 2 times 5, or the natural log of 10. Our previous lower limit of integration was e over 2. So x equals e over 2. We're going to transform that. Our new limit, our u, is going to be the natural log of 2 times e over 2. And 2 times e over 2 is simply going to be e. And the natural log of e is 1. So our new limits of integration, our lower limit will be 1, and our upper limit will be 10. So what we end up with here is 7 times the integral. My new lower limit is 1. My new upper limit is natural log of 10. My integrand is 1 over u. And my differential, du. So what we're claiming here is that the original integral represents this area in blue on the right. And this integrand is difficult-ish to integrate. It doesn't look like a lot of fun. Whereas we can, as an alternative, find this area on the left that's in yellow. We've transformed the integral. The area of the yellow region on the left is the same as the area of the blue region on the right. And this second integral on the left is much easier to evaluate. So let's go ahead and evaluate. So we end up with 7 times, now my antiderivative of 1 over u is the natural log of the absolute value of u, and we will evaluate from u equals 1 to u equals natural log of 10. Now, substituting in these limits of integration, the upper limit first, we get the natural log of the natural log of 10 minus 7 times the natural log of 1. Now recall that the natural log of 1 is 0. So our final value is 7 times the natural log of the natural log of 10. I hope you find this helpful.